What is different about question number 3 from the first two? We're solving, not proving. So the key command word here is solve. And we want to make sure that we read those command words, because if you try to prove this, it's not possible, and then you'd get stuck and wouldn't be able to get anywhere. A couple of other things that tell you that it's probably a solving question. They give you a domain over to solve. That domain tells us what? Tells us whether we're in radians or degrees. We know that we have to be in radians. Okay? I haven't told you whether this is a calculator question or a non-calculator question yet. So we're going to assume we're going to do as much as we can without a calculator. And then we're going to see if we need a calculator in the end. Okay? So when we look at this equation, though, we have 3 minus 3 cos x minus 2 sine squared x. We've got two different trig functions in this. And we can't solve something if we have two trig functions. Unless, well, we're going to get to some questions where we will have two trig functions and be able to solve it, but we're not there yet. Up till now, we can't solve things if there's two different trig functions. So our main goal would be, can you change something in this so it has only one trig function? And what would that be? Well, we know that sine squared plus cos squared is equal to 1. So what could I write instead of the sine squared? Yes, 1 minus cos squared. So one of the things you're going to find that you're able to do quite quickly in your head is take any of those three Pythagorean identities, sine squared plus cos squared equals 1, or the one with tan squared and secant squared, or cotangent squared and cosecant squared, and rearrange them in your head to get something by itself. So if you wanted to get tan squared by itself, you'd move the 1 over to the other side and get secant squared minus 1. If you wanted to get sine squared by itself, you're going to move the cos squared over to the other side and get 1 minus cos squared. And once you've done that, well, now we've got an equation with only one trig function. So we're going to do some rearranging, multiply things out, multiply that 2 through, and it's a quadratic equation. Combine our like terms. I'm going to write the cos first, minus 3 cos x, 3 minus 2 is plus 1 equals 0. And see if we can factor this. If you can't factor it, then you're going to have to use your quadratic formula, which is on your formula sheet. So we're going to hope we can factor it. If it could be factored, does it make sense that it's going to have to be 2 cos x and cos x? That's the only way you're going to get 2 cos squared. In order to get 1 as your last one, it would have to be 1 and 1 if this is possible. Is there any way to get minus 3 with our outside and inside? We'd have to have negative and negative. That would get us minus 3. Now we do a quick check. If we multiply this all out, does it work? We've got our minus 3. Minus 1 times minus 1 is positive 1, so that's good. And 2 cos times cos is 2 cos squared. So if that's the case, we have cos x equals 1/2. And cos x equals 1. Do we need a calculator, or are those on our pie plate? Those are on our pie plate. When is cos x equal to 1/2? What family? Pi over 3, which quadrants? Quadrant 1 and quadrant? All right, we'll look at that after. Quadrant 1 and quadrant 4, right? So you're right, that's not included in the domain, but we'll write all of our answers from 0 to 2 pi first, and then we always check our domain at the end. So this one we are going to find out is going to get canceled out after, because quadrant 4 isn't in the domain. But for right now, let's solve it between 0 and 2 pi, and then cancel things out afterwards. Is cos x equal to 1 on our pi plate? 2 pi and 0 and 2 pi. So you get so used to solving things between 0 and 2 pi that you probably are going to do that naturally. Then you're going to look back and say, our domain is looking between 0 and 3 pi over 2. This one's in quadrant 4. 3 pi over 2 ends at quadrant 3. 2 pi is all the way around, and if we end at 3 pi over 2, that one's not going to be included. So there's only two answers, 0 and pi over 3. All right. Question number 10 is another one that you can do there.